You had 2 lectures previously with Piotr, and today we have a lecture about IoT hardware. I'll tell you a few words about microcontrollers, microprocessors, boards that can be used in IoT systems, but not only. We'll talk also about other elements. My name is Krzysztof Tokarz, and today about hardware. We will talk about hardware infrastructure. We will talk about some examples of microcontrollers, single computer boards, and similar elements, and few possibilities how to create your own IoT device. I'll tell you some hints, maybe how to do it. There is such a commonly known picture that shows the data flow in IoT systems. Here on the bottom part of this data flow, we have sensors, and sensors, of course, produce some information. We can this information gathered by our local device, and in IoT, sometimes this local device can process data and influence the actuator back, or control the actuator back locally. Yeah, it can have some algorithms built in, and we can process the data locally. But if the number of data, if the size of data is too big to be processed by this rather constrained device, that is IoT node, this data can be sent to some upper levels of the hardware, and it can be done through some kind of local network. It can be Bluetooth, it can be Zigbee, it can be a Wi-Fi or some other possibilities. We can have here local storage, because if we have some local device, it can be a little bit bigger device comparing to our local processing device, local node. Sometimes the local node is constrained device like AVR, like Arduino or similar. We can say this level is the edge level of our IoT system. Next, we have local processing, and this is something, it can be considered like fog set of devices. So this local processing here can be done like something like Raspberry Pi or small PC computer. If we want to pass this data even higher, on the higher level, we use gateway to the internet, use the internet itself to transmit data, for example, to bigger server or to cloud. And on the cloud level, we can have cloud processing. So this loopback between sensor and actuator we can have here locally. We can locally in the IoT node. We can have in our local system, and we can also have here in cloud system. And we will not talk about cloud processing. This is out of scope of our here IoT our IoT classes. We will talk mainly about processing here, but about the hardware mainly here. As the local processing node, we will use bigger computers like our PC computers. Typical local IoT network infrastructure can look like this. Here we have set of IoT devices, as I said, rather small constrained devices that generate some data like sensors, that can control some elements like actuators. All these nodes are connected through some network to access point. This can be access point, we are not talking about Wi-Fi access point only. This can be access point, for example, for Bluetooth or for Zigbee. We have router to the internet if necessary, and the local processing computer. Typical IoT device, so such, the low-level constrained device, we can consider as embedded system, but equipped with networking capability. This is the difference between our embedded system computer and IoT computer. IoT computer must incorporate the networking possibility. So we have here embedded system, we have communication unit. Of course, if we have an embedded system, we have some embedded software that works on this computer. We have sensors and actuators. And few words about what is the difference between embedded systems and IoT. Embedded system, special purpose system in which the computer is completely encapsulated by the device it controls. So embedded system we consider as the computer that controls something bigger, like, I don't know, washing machine, microwave oven, machinery in industry, or a robot or something like this. So the bigger device is this dark blue ellipse here, and the small is embedded system, that is computer that controls this machinery. And what is the difference between embedded system and IoT device? As we said, embedded system doesn't need the communication unit, while IoT node must be equipped with some possibility to transmit data. If we don't have data transmission, it can be wired, it can be wireless, doesn't matter, but there must be the data transmission. It even can be data transmission one way. So for example, we have some simple tag or simple beacon, yeah? It just sends the data, but it can be considered as IoT because we have the data transmission. So we can say that IoT device is embedded system with networking module. And now few words, a few slides about elements of IoT devices. What's inside? What they include? First, microcontroller. We can say that almost every embedded system IoT node needs some microcontroller or microprocessor, but normally, usually in modern world, there are microcontrollers, and we can have different families of microcontrollers inside, starting from 8-bit AVR microcontrollers. They must be equipped with some additional networking module. We can use some 32-bit microcontroller like ESP family. ESP is the family of microcontrollers created by Espressif company. It can be also microcontroller based on ARM core. We will talk about different examples of such elements. Normally, such IoT device incorporates also some sensor. So this is just a list of available sensors, of course not exhaustive list. So we can have some simple switch, we can have a sensor for temperature, for humidity, pressure, some other physical parameters like, I don't know, light, color. We can detect pollution, we can detect some gases, we can detect physical phenomena like acceleration, like changes in magnetic field, many others. We will talk about possibilities of different sensors in the moment. We can have also actuator to control the environment, to have the influence or some output for the user. So here we can have simple lamp, LED. We can have display just to show some texts using alphanumerical display like on this picture. We can have graphical displays. We can have relay to control something that needs bigger power like heater. We can have motor to move something or to turn something. We can have a speaker or buzzer to make some noise and inform using acoustic wave some user that something happens, and also valve pumps to have influence, I don't know, on heating, on some plumbing and water flow. As we said, we need the communication module to have IoT device. This can be wired network like Ethernet, very popular wired network. It can be Modbus, for example, for industrial purposes. It can be also RS485. This is also interface that is quite popular in industry plants. A communication module can be wireless, of course, and I think in modern world the most popular communication possibilities are use the wireless connectivity. Very popular is Wi-Fi, because Wi-Fi is achievable almost everywhere now. But in IoT, because Wi-Fi is more power consuming, there are also other possibilities invented, like Bluetooth Low Energy, Zigbee, and additional Z-Wave, Thread, Matter for longer communication, LoRa or GSM. So everything depends on the needs, everything depends on the range of transmission that we want to obtain, and everything depends, of course, on the availability of other technologies nearby. And we start details about talking on some popular hardware platforms. So we start with microcomputers. I will rather show you here not the separate chips, because the separate chips maybe are not so interesting. Rather, for creating some IoT device, it's more interesting to have the ready microcomputer, like Arduino, for example. So I will show you here a few examples of different microcomputers based, of course, on microcontrollers, sometimes on processors, that can be used to create the IoT node device. Here we will talk mainly about IoT node devices, but on some computers that I show here, it is also possible to create this higher level, so we can say this fog level of devices. Let's start with the most popular, Arduino. I think everybody knows Arduino, or at least everybody heard about Arduino. But notice that Arduino Uno, as I show here, this is not IoT device. It must be equipped with some communication module, because Arduino Uno is microcomputer, very nice, but it doesn't have networking possibility just on the board. So you need to equip it with some additional modules to have IoT device. But few details about this Arduino. It is based on Atmega microcontroller, so series of AVRs, the specific model Atmega 328. This 32 means how much memory it has built in. So it has 32 kilobytes of flash memory for program. It has also some RAM memory for data, so 2 kilobytes for data, and also additional 1 kilobyte of EEPROM memory to store some parameters that should be remembered while the power is off. Oh, for example, some network credentials or something like this. As you can see, the clock speed of this microcontroller, so this AVR is not very high, it's 16 megahertz, but it has RISC architecture, so quite fast architecture, and allows to execute most instructions in one cycle of this clock. So the speed of execution is quite enough, for example, to control devices like the 3D printer. Arduino has digital inputs and outputs, so we can connect variety of different devices, different elements, electronic elements to it, both digital and analog, so many sensors, actuators that I will show a little bit later. Another version of Arduino, quite popular, Arduino Leonardo, Atmega 32U4 microcontroller. This U means that the chip itself has built-in USB module. So there is no need to additional element that was here. Here was the additional element, that is converter from USB to serial port of microcontroller. Here this converter is not needed anymore because USB possibility is built in the chip, so no additional elements are soldered here. This version of Arduino microcomputer has some digital I/O pins, has also some analog pins. The numbers are on the slide. It has similar amount of flash and RAM memory and the same clock speed because all Arduinos, the base Arduinos based on AVR microcontrollers have the same core of the processor inside, yes, clocked with 16 megahertz and executing the same set of instructions. Another Arduino quite popular is Arduino Mega 2560, and this is bigger version, we can say. This is the version that has a lot of GPIOs, general purpose input outputs, up to 54, and as this it is used in very sophisticated projects like, as I mentioned, 3D printer. The most 3D printers, popular 3D printers are based on this version of Arduino microcomputer. Other elements are similar, but it has bigger flash memory for a program, 256 kilobytes, and a little bit bigger RAM memory because it is 8 kilobytes. We have bigger version, but we have also smaller version. We have small version Arduino Nano based on Atmega 168 or 328. It has less digital pins because we have here 14 pins, 8 analog inputs, flash memory is 16 or 32 kilobytes, depend on the version of microcontroller, and the rest parameters are very similar to previous. As you can see here, we have also USB plug or socket to be connected to PC computer. There is also such nice idea, such a round-shaped Arduino named Lilypad that is intended to be glued or mounted on the clothes, so like wearable device. It is based on similar microcontroller as the previous one, but it doesn't have USB connection. So it doesn't allow to be programmed directly, it needs external programmer. But in such a situation it consumes less power, so it's better for wearable devices. And it has reduced clock speed to preserve the power during program execution. As we said, Arduino itself cannot be the IoT device because of lack of communication, wireless communication or wired communication in the network. So there are shields that extend the possibility of Arduino boards, like for example communication shield based on WizNet controller. It allows to connect Arduino to Ethernet network, so wired network. But there is also Wi-Fi shield available. There are also Wi-Fi modules available. I'll show some such modules in the moment. But we have also Arduino boards that incorporate networking possibility on board. Two examples. One is Leonardo with Ethernet. It has built-in such WizNet controller. And another is Arduino Yun. This is quite interesting approach because it has two processors on the same board. On the one layer of the board it has Atmega processor, so Atmega 32U4. On the opposite side of the board it has Atheros processor with MIPS architecture, and the Linux can be uploaded to this processor and executed on this opposite side of the board. So we can say we have two computers on the same board. One computer is equipped with Wi-Fi connectivity, also with Ethernet connectivity. So this Atmiga microcontroller here is rather such, we can say, smaller brother of this bigger Linux computer on the same board. Another computer that I want to show you is Raspberry Pi, the whole family of computers, and they cannot rather be considered as constrained devices. So mainly such computers are used on this fog level, not on the edge level. They need more power. They rather need to be powered with the constant power supply, not the battery. Of course, it is possible to power them with the battery, but you know this battery will be drained quite fast. So they can be used mainly as, you can say, central points to connect many IoT nodes to them to gather data and process the data and at the local level. Raspberry Pi version 2 is based on the ARM processor that is clocked with 900 megahertz quad-core processor, so quite powerful. 1 gigabyte of RAM, 4 USB ports. It has such header with the connections with GPIO ports, so you know we can control some elements directly from it. We can also read some sensors and connect some sensors to Raspberry Pi. So you know, if you want, you can do this edge level device basing on Raspberry Pi computer. This version has Ethernet connectivity and also camera interface, display interface, so it can work just almost like normal computer. The newer version is Raspberry Pi version 3. It has also quad-core processor, but with higher frequency, 1.4 gigahertz. It also incorporates wireless connectivity, so it has the Wi-Fi module built in, Bluetooth 4.2 version. 4.2 version allows us to use the Bluetooth Low Energy protocol that is specially designed for IoT. So this can be central point for different sensors that use Bluetooth Low Energy connectivity. It has also Ethernet port, HDMI for the for monitor, for example. Can be powered with USB port or power over Ethernet. Raspberry Pi model version 4, it has even a little bit faster processor, also quad-core processor, 1.5 gigahertz, bigger RAM memory because up to 4 gigabytes of memory. It also has Wi-Fi with the 2.4 gigahertz, but also 5 gigahertz. It has Bluetooth, Bluetooth Low Energy, Bluetooth 5, so version of Bluetooth that connects different versions of Bluetooth together. 1 gigabyte gigabit Ethernet, 2 HDMI ports, so we can even connect 2 monitors to this, and USB 3.0, so this is quite powerful computer. And because it's powerful, it consumes a little bit more power than previous versions, and of course more than Arduino computers. Another interesting possibility is maybe not so popular as Arduino and Raspberry Pi. Yes? Oh, yeah, of course. Mm-hmm. Yeah. Yes, of course. Of course, there are also other versions. I'm not sure if someone who watches this video heard our student shown us the Pico version of Raspberry Pi. So there are also other possibilities. Of course, I cannot show all the boards that are available on the market. I show just subset of them. Something created by Intel. I'm not sure if it's available anymore, but I think it was quite interesting that Intel also wanted to be in this competition on this IoT market. We have Intel Edison based on Atom processor, 1 gigabyte of RAM, 30 I/O pins. Unfortunately, these pins were here available on very specific and very small socket, so it was totally impossible for enthusiasts and amateurs to solder such connection. So the connector, it wasn't so easy to use it. But it could support Wi-Fi and Bluetooth connectivity with half gigahertz of clock of the processor. Another board is BeagleBone series of boards. These are boards created, we can say, in such open source way. Based on Texas Instruments, ARM Cortex, BeagleBone Black, because different versions have different processors. It has 4 gigabytes of eMMC for programs. It has also half gigabyte of dynamic memory for data, 65 digital pins, 7 analog pins, Ethernet, also connectivity for audio and video using HDMI port, 1 gigahertz of clock of the processor. We have also wireless versions with Wi-Fi, Bluetooth low energy, so also quite interesting boards. I remember some students made projects based on these boards, and they were quite nice and interesting. Something also from the same group of people who created BeagleBone, Beagle Connect Freedom, based on Texas Instruments CC1352 chip. This is such series of chips that allow to provide wireless communication in different standards, for example Bluetooth, Zigbee, and other standards like 802.15.4. This one is based on 38 megahertz ARM processor with some less than 1 megabyte flash memory, quarter kilobyte of RAM memory. It is okay. We have 144 kilobytes of static RAM. We have cache memory here, and Bluetooth and communication, commonly known as sub-gigahertz. So, for example, 868 megahertz that is normally used in remote controllers. It has also LEDs and buttons, so they can be used as rather small node devices. I mentioned at the beginning about ESP processors or ESP system on chips, because rather we can consider them as system on chips. ESP are designed and created by Espressif company. This Espressif company bought the IP core of the processor from Cadence. This is Tensilica processor, and they created the radio, Wi-Fi capability, and these chips became very popular among students, enthusiasts, and amateurs that wanted to create their own IoT devices. That's why I mentioned about this possibility and about these chips here. The first member of the family was ASP8266. First popular was this one with 80 megahertz of clock, 64 kilobytes of instruction RAM, because it executes instructions after fetching them from external flash to internal RAM. 96 kilobytes of RAM for data, up to 4 megabytes of the external program memory connected using quad SPI. It uses Wi-Fi, so ESP8266 uses Wi-Fi only, with WPA2 authentication, so maybe a little bit outdated now, but you know, this is the first popular chip from this family. It has 16 GPIO pins, and some interfaces like SPI, I2C, UART, and also analog to digital converter. It was based off some interesting boards. So the boards I show now, they are all based on this ESP8266. So the overall functionality is the same. The difference is the number of pins and possibility of programming or necessary of use the external programming module. So for example, ESP01, it has just 3 pins, 3 GPIO pins. Other connections are used for providing power supply and programming. It needs the external programming unit, but the benefit is that this is very cheap element. There is also a smaller version named ESP01D that is very often used in, for example, electric bulbs, remote controlled electric bulbs. So I have found such element in the bulbs very often. It is based on ESP8285 chip that is flash memory built in. Another module available based on this ESP8266 is ESP12E. As you can see, it has more pins around, but it needs some special board to be soldered. A very popular module named Node MCU, based on this module ESP12 soldered in already, so it's quite easy to use it. It can be connected or plugged into some socket, into some experimental board, and connected with simple wires to another elements. This exposes 10 GPIOs, and normally the software that comes from this module allows us to program it with scripting programming language that is named Lua. And what is very nice with this board, it has the USB socket here, so we can plug it directly to PC computer and program it even using Arduino framework. So this is very easily to be programmed, and a lot of different libraries are available for this. It has Wi-Fi connectivity, so this is the base board for many interesting projects. You can find them in the internet. Another interesting board is VT Cloud, also made on this ESP8266 micro or system on chip. This has RGB LED here, and we can change the color of this LED, and we have also light sensor here, so we can measure the intensity of the light nearby. It has also 2 push buttons for controlling it, and the lower board here, the bottom board, is the programming unit. So we can plug the programming unit or unplug it and use the VT Cloud board itself. Very popular, interesting board, Wemos D1, and even more popular D1R2. It is, as you can see, based on the similar module here, so ESP12, but the overall shape of this board is like Arduino. So this one allows us to connect Arduino shields and use them as normal, almost normal Arduino. What is the difference? Difference is the voltage, because the ESP8266 must be powered with 3 volts, while Arduino is powered with 5 volts. So not every shield will operate properly. Another thing is that this ESP doesn't have as many GPIOs as AVR, so not all pins are available here, but most of shields can operate normally, so we can we can create some interesting IoT devices based on Wemos D1 and some Arduino shield. Of course, we have Wi-Fi connectivity here on board, and built-in programming module like in Arduino. Here is the converter from USB to serial port, so we can program it directly, connecting it to our PC computer. There is also smaller version of this Wemos D1 called Wemos D1 Mini. A very nice board. It is the base for many projects, students project and others. And there are also shields created for this module. They are available for buying. Very small shields, very nice. We have, for example, button shield. We have LED, RGB LED shield. We have shield with the display, with relay and other also. It has built-in programming module, so we can plug it directly with USB cable to our computer and write programs. And the newer member of the family from Espressif is ESP32. ESP32 is based on similar extensor microprocessor, but it incorporates also additional coprocessor for ultra power mode, so for power saving. The main processor has higher frequency, clock frequency, comparing to ESP8266, because it can operate up to 240 megahertz. Yeah. It has half megabyte of RAM memory inside, Wi-Fi, and also Bluetooth. So this is very interesting that here we have also Bluetooth and Bluetooth Low Energy. We have all libraries written for Bluetooth in Espressif programming framework, so you can create your own devices using this chip and using Bluetooth connectivity, and all other elements are similar to ESP8266. We have some GPIOs, we have also analog to digital converter, we have also some internal cryptographic hardware to support safe communication. The boards that are built basing on this ESP32 are like this. Some examples: DevKit ESP32, similar to this Node MCU, as you can see, but pinout is different. Unfortunately, I don't know why they changed the pinout for different boards. We have such module based on this ESP32 known as ESPW room, with building programming module, so we do not have to worry about programming interface. We just connect it to PC computer. We have also D1 Mini with extension to 32-bit to 32 processor, ESP32 microcontroller or system on chip. It has 2 rows of pins here. One row is compatible with this D1 Mini based on ESP8266, and another row is, or another 2 rows are extensions to it. With built-in programming unit, very nice chip. It can replace D1 Mini in applications that requires Bluetooth transmission. There are also boards equipped not only with system on chip like ESP32, but also additional elements. This is quite interesting board that has, as you can see here, display. This is OLED display, but also it has here antenna for LoRa communication, LoRa long range communication, special protocol designed for communication up to a few kilometers of range, consuming not big energy. So this is quite interesting if you need to create the device that needs some longer communication than Bluetooth and Wi-Fi. For example, you have some, I don't know, something for measuring in a field, and you are in the range of LoRa communication. So, for example, 10 kilometers, you can obtain the data from such device. What is important? You can use LoRa if you if you keep the restrictions, low restrictions on the communication with LoRa, you can use it completely for free without any subscription needed. There are also new versions of ESP32, just few of them because there are also some additional versions. There's S series, that this new version of original ESP32. S2, this is faster processor but single core. More security and AI capabilities. It incorporates some additional cryptographic elements. We have also S3 that supports higher speed protocol to communicate with flash memory, AI instructions, and like original ESP32 is dual core. There is also C series. C series is created as the, we can say, direct replacement of the outdated ESP8266. C3 compatibility on the pin level with ESP8266, but higher level of security. C6 is similar to C3, but it supports Wi-Fi 6, and C5 implements dual band radio for Wi-Fi 6 and also normal Wi-Fi. And H series supports other protocols than Wi-Fi and Bluetooth. So it can support, for example, Matter, it can support, for example, Zigbee. So quite interesting chips. H2 have Thread and Zigbee, additional to Wi-Fi and Bluetooth, of course. So it was just, the subset of all elements that you can find on the market. I have chosen some popular and some interesting ones. And now a few words about how to create, basing on the hardware that you have, how to create your own devices. Sometimes you don't even need to use the soldering iron, yes, because maybe you are afraid of soldering iron. You can create your own IoT device, just having some element board and some wires maybe. 4 different ways to go that you can use, that you can go to create your IoT device. First, use the ready-to-use networking-enabled development board. So I've shown you some examples of this board. If it is network-enabled, you just write your own software and you have IoT device. Another, you can take some microcontroller board or microcomputer like Arduino and connect some networking module to it. This module can be Wi-Fi module. For example, you can use ESP01 as the Wi-Fi module for Arduino. You can use some Bluetooth module maybe. So this is another possibility. Another possibility is to use the development board and create the extension by yourself. So you can take some board that is, for example, Wi-Fi or some Wi-Fi module, Bluetooth module, and connect to microcontroller by yourself. And the last, sometimes it is possible to buy the ready device that has some functionality and try to reflash it. I know it's not, it needs some additional knowledge, but you are becoming engineers, so such thing shouldn't be very complex for you. Just have the ready device, try to open it, but be careful about the power mains. And if it's inside, and try to, for example, write your own program for this device. If it's based on the popular microcontroller or system on chip like ESP32, it is quite possible. Ready to use board. The example. This can be module based on ESP8266, ESP32, some Texas Instruments, NRF52 or other system on chip. Here, this is, of course, the picture of the ESP8266 D1 mini module. And we can expand its possibilities using shields like here. Yes, here is the stack that incorporates some temperature sensor, LED, and also pressure sensor we have here. You can use microcontroller board like Arduino here. So you take ready microcomputer, and it must be expanded with the networking module. So you connect to Arduino here ESP01 that works as Wi-Fi module that enables you to connect your Arduino to Wi-Fi network. What is important here, different boards, different elements can have different voltages. So these voltages must be observed to not burn something. Yeah, if you provide too high voltage to the board that doesn't accept higher voltage, you can damage it. So the voltages always must be observed if you connect different elements. This can be done using some experimental boards like this white board here, sometimes called breadboard. Another possibility is to use the microcontroller board, and you can even test virtually if it can have a chance to operate. There is example of such interactive web tool named Walkway. There is also Tinkercad by Autodesk. There is also something like Virtuino. This is offline, you need to install it, but you can test if your connection, if your device that you create could work properly. And the ready device, sometimes some devices are that are available on the market are based on some popular microcontrollers or system on chips like ESP8266 or ESP32. You can try to reflash it. Sometimes it is even possible to reflash it over the air, so using just Wi-Fi connectivity. Maybe not this times because producers block this possibility, but maybe you will find such device. Sometimes you need to open it, sometimes you need to unsolder the microcontroller board and connect it directly from your computer. Please do not connect the device to the mains and to your computer and don't touch this device inside if it's connected to the power mains. But yeah, if it's not, you can always experiment something. Okay, so I think that's all I wanted to tell you about this computer part of IoT devices. And next time we will talk about some actuators, sensors, and some additional elements that create IoT node.